Thank you, Gary. And do I just go this way? Yes, except that's not my first slide. There we go. Okay, the other disclaimer is that I am not an expert in cardiovascular diseases, but know enough around the edges to know some of the literature about mercury and this endpoint and recognize that this has potential large implications if this premise is causal enough or true enough to be used in the way that I'm suggesting here. So this issue is important not just for cost-benefit analysis, but also for the way we do fish consumption advisories, because right now we just target the neurodevelopmental at-risk group, pretty much women of childbearing age. And also this dovetails into the connection between chemicals acting at low dose on the backs of already high diseases that are common in the population, so that it's, at low dose, maybe this is the important thing to try to understand, is how chemicals may be contributing to what's already prevalent in the population. So anyway, I've just laid it out with a couple of arrows here, the key being methylmercury. The pro side here is going to contend that it is a contributing cause to cardiovascular disease and thus should be factored into cost-benefit analysis. There had been an analysis of this concept in 2010, 2011, in which recognizing that the mercury that's contained in fossil fuels may be important to regulate from the perspective of its environmental release from power plants and getting into aquatic systems where it can readily go up the food chain. And then the top predator in that cycle, being human beings, could be, and by the way, the major source of mercury exposure for human beings is fish. So this pathway is the key pathway when we're talking about exposure to organic mercury, thiomerazole or whatever else, is really small compared to this. That cost-benefit analysis, I believe is 2010, it says there, by Glenn Rice et al., showed that 20% of the cost benefit or the benefit from reducing mercury would be related to neurodevelopment and protection of IQ, and 80% if this is causal enough to be factored into cost-benefit analysis, the benefit would be from prevention of myocardial infarction. So. Here is a little bit more of that analysis. I hope you can, I guess you may be hard time reading the fine print, but they laid out back in 2010, 2011, as a result of an EPA-led workshop, they laid out the various lines of evidence from epidemiology, animal, and in vitro work on sort of the mechanistic, molecular interface kind of level of effect of methylmercury through to intermediary clinical endpoints like thickening of myocardial endothelial tissue and thickening of the myocardium, and to the final endpoint, which would be myocardial infarction, and laid out the level of evidence. The conclusion in 2011 was that the workshop recommended the development of a dose-response function relating methylmercury with myocardial infarction for use in regulatory benefits analysis. So that was 2011. Obviously, I've updated the literature search on this with some other interesting endpoints as well. So here's the basic data. Along those lines, the main study, there are two main epidemiology studies showing mercury associated with myocardial infarction and acute coronary events. And this is a prospective study from eastern Finland where the fish, there's a relatively high fish-eating population, and the fish are middling in mercury and low in fish oils. So these are lean fish, not a lot of omega-3 fatty fatty acid, and 13.9-year follow-up. At baseline, these 42 to 60-year-old men did not have cardiovascular disease. They measured mercury in the hair and then followed them out all those years. And the highest tertile of that group had about a 1.7 to 1.8 fold odds ratio for acute myocardial events. I guess, oh, okay, I didn't realize I had that phased. And then in terms of, okay, so go back. Yeah, so the points at the bottom there is Virtanen et al., this Eastern Finland cohort shows temporality because it's a prospective study. It shows dose response. Well, at least because the highest tertile had the effect. And then in Gualar et al., 2002, 684 cases from a combination of 8 countries across Europe and Israel, also show a dose response. This is not prospective, but shows a dose response based upon a mercury biomarker and acute myocardial events. So getting back to the Eastern Finnish cohort now, in terms of upstream subclinical evidence for this endpoint, they showed that mercury was associated, again in that same prospective design, associated with increased thickness of the intima media. So the coronary arteries were thickened in these Finnish men, the higher, and these are the, I guess, quintiles, 1, 2, 3, 4, 5, yeah, quintiles of exposure. That highest group had a 2.81 fold odds ratio for thickened intima media. So this is not the only cohort that has shown this in relation to mercury. In the Faroe Islands, Choi et al., 2009, and also in a group of non-fish-related exposures, but in a chemical plant in Poland, also had thickened intima media. Those two were not prospective, so we have 3 different groups showing this thickening related to, again, mercury biomarker. Okay, so then, well, there's going to be epidemiology on both sides of this. One of the main ones is Mozafarian et al., 2011, and they showed, the red line is what they showed, and the blue line is a simulation that I produced related to this study. So the red line, and the big headline news is that from this study, this made national news, this study, was that mercury is not associated with increased cardiovascular risk. In fact, the more mercury these 33,000, this cohort of 33,000 was actually 2 separate health-related worker cohorts. The more mercury that they had as a biomarker, this was toenail mercury, but I've converted to hair mercury for other things that I was doing with the data. The more mercury they had, in fact, it was protective. The risk went down. And what could that possibly mean in terms of all the mechanism things I'll talk about in a minute, is that it likely is a biomarker for fish ingestion. And that if you're eating fish with a little bit of mercury and some other beneficial nutrients such as omega-3 fatty acids and other anti-inflammatory ingredients, and it's also, fish is a good low fat source of protein relative to other sources of protein, that you might exactly expect to see this mercury not only as a biomarker of exposure to a toxic heavy metal, but it's also a biomarker to ingestion of fish. And so what I did with this evidence was looked at the dose response for omega-3 fatty acid, which is the left graph, and the Gualar data I just showed you. So the one on the upper left is the beneficial curve for omega-3 fatty acids on cardiovascular endpoints. The right one is the risk that I just showed you of methylmercury. And if you do a risk-benefit equation for these 2 respective slopes, you can exactly reproduce, which is what that blue line is, not exactly, but you can come close to reproducing what they showed just by simulating the omega-3 benefit in the diet that these people were likely eating. So with that, basically what I'm trying to say in a nutshell is that that paper may well be heavily negative confounded. And when you start trying to tease that apart mechanistically, you may be able to see that confounding through these different slopes. So in terms of plausibility, does an AOP exist? The top line is the overall construct that we're working within in terms of molecular interaction, and then the biological response inside the black box. We don't really know what's going on, leading to something measurable, an adverse outcome at the right. Well, for methylmercury, we know, let's see, I can see it clearer here. We know that it's very reactive with protein sulfhydryls, causing a lot of protein denaturation. And one particular protein that's that has been shown, and I'll show you this data in a minute, is that paraoxidase 1 or PON1. We toxicologists think of it as being protective against organophosphates. However, PON1 has a different function. It wasn't created just to fend off organophosphate oxones. It was, it has been through evolution built into high-density lipoprotein. Okay, to fend off oxidized fat and to prevent fatty streaks from developing. And it's well known in populations that have low PON1, that is a risk factor, predictive risk factor for acute myocardial events. So mercury knocking down PON1 is an intermediary step, a biochemical step, creating oxidized lipids, promoting fatty streak, redox effects of mercury, oxidative stress, leading to increased phospholipase activation and COX pathway activation. Also, mercury's been shown in vitro to decrease nitric oxide availability. All of that in the endothelial cell, which is very sensitive to oxidants, can lead to damage and a fatty streak, increased intima media. So there is a plausible mechanism. And then on the bottom is, well, this is already going on in the population through related pathways, and it's quite plausible that mercury would be contributing to what is happening in the population overall. So here's the evidence from Aboriginal fishers up in the Arctic Circle that their PON1 goes down the more mercury they have as a biomarker. And actually, the 0.1 microgram per kilogram per day dose that I've overlaid with that dose response from my et is the RFD. So at the RFD for mercury, we've got already a knockdown in circulating PON1. So plausibility also is some of this mechanistic work from rats, showing that mercury increases superoxide generation in arteries, decreases nitric oxide generation, which is a vasodilator. So increases, basically dysregulates the vascular function of rats. Methylmercury relatively, this was a low-dose study. So in summary, the epidemiology associations with coronary events are suggestive that at levels common in the population, you can see in the Finnish study and in the European study, you can see this association with acute myocardial outcomes. The epidemiology also shows a correlation with upstream events, such as decreased PON1, thickening of the intima media, all make sense from a clinical progression of disease perspective that's already happening in the population that mercury could be adding to. Experimental evidence in animals and cells shows that mercury is going to stimulate ROS, protein denaturation, dysregulation of vascular function, leading to oxidized lipids, endothelial dysregulation, and vasoconstriction and fatty streak. And so strength of association, I would, from the perspective, call it moderate to strong. Several studies, several endpoints. You've got temporality because of the various prospective endpoints in the Finnish data set. You've got a pretty strong mechanistic support for a plausible association or plausible mechanism. Dose response is there, and there's clearly, I think, more research needs on the intersection between methylmercury, cardiovascular effects, and background disease in the population. But overall, The evidence from 2011 was there to suggest it should be used in risk-benefit, cost-benefit, and I haven't seen anything since then that would argue against that.